Okay, so classwork 3.1. What I like to do is I like to go through this and pick one problem from each section and just talk you through how to do it. That way, when it's your turn to do the homework, do the classwork, you can use this video to help you do it. All right, so we'll do the first one in each section. All right, so a coin is tossed. Find the probability that the result is heads. All right, you have two possibilities. One is desired, so 1 over 2 would be 0.5. You just do the number of positive events over the sample size, and you'll get your probability. Let's go down to the next section. Short answer. The data in the table represents the number of consumer complaints against major U.S. airlines. If one complaint from the table is randomly selected, find the probability that was filed against the United Airlines. All right, United, there was 1,172 complaints. So this is the probability of a complaint over the total. So you would take these three quantities, add them up, and it would be 1,172 divided by this total. The section you do the same way for all of these. All right, here's multiple choice. Let's do a multiple choice one. The distribution of blood types for 100 Americans, so that's your sample size, is listed in the table. If one donor is selected at random, find the probability of selecting a person with blood type A positive. So there's 34 A positive. Your sample size is 100, so it's 34 divided by 100. That's how you do this section. Remember, look at 18. When you have a tone like this, make sure you add, to do sample size, add up all of these. All right. Use the following graph, which shows the types of incidents encountered with drivers using cell phones, to find the probability that a randomly chosen incident involves cutting off a car. So that's this one here, cutting off a car. So what's the probability? So if it's cutting off a car, P of cutting off a car is 20 over the total. So you would add these up, 44 plus 40 plus 20 plus 19. So it would be 20 divided by the total of all these frequencies. Same thing with the pie chart. Do the same way. All right. Here the question is. Question has 5 multiple choice answers. Find the probability of guessing an incorrect answer. All right. So you have 5 multiple choice answers. One of them is correct. 4 of them is wrong. So it's 4 out of 5 is the probability of getting a wrong answer. All right, now we're going to identify sample space. Identify the sample space of probability experiments shooting a free throw in basketball. All right, so when you show a foul shot, you either make it or you don't. So the sample size is 2. Make it or don't make it. So you're looking for sample size there. Identifying simple events. That's a very specific an event, not a subset. A computer is used to randomly select a number between 1 and 1,000. Event A is selecting a number greater than 6,000. Is this a simple event? All right, a number greater than 600 could be 601, 602, 603, all the way up to 1,000. So the probability of picking a number greater than 1,000 is 400 over 600, but this is not simple because this is not a specific single event. Fundamental counting principle. So this is when you do the product of how many different sample sizes for each there are. So a shirt company has 4 designs. And each design has a short sleeve and a long sleeve. That's 2. And there are 7 color patterns. So using the fundamental counting principle, it's 4 designs times 2 sleeve lengths times 7 colors. So 4 times 2 is 8. 8 times 7, that is 56. There are 56 different shirts available from this company. Classifying types of probability. All right, so we have classical, which is kind of like laboratory, empirical, which is based on statistics, or subjective, which is gut feeling. Classify the statement as an example of classical, empirical, or subjective. The probability that a train will be in an accident on a specific route is 1%. So this is probably subjective, because doing an experiment to see how many times trains have an accident is way too costly. But I mean, it could be empirical if they've kept data on this particular track for years and years and years. They could see that, how many times it's been used, how many times there was an accident. But I have a feeling that it's subjective. Concepts. Remember, what can and cannot be a probability? Probability is between 0 and 1. Which of the following cannot be probability? 68, 0, 0.001, or 0.3? 68. It's not between 0 and 1 inclusive. All right? Now with these, just convert all of them to decimal and then figure it out. All right? Remember, probability cannot be greater than 1. Short answer. Write the word or phrase that best completes each statement or answers the question. Explain why the following statement is incorrect. He gave 110% effort. There's no such thing greater than 100%. So it can't be. It's 0 to 100%. There doesn't exist that extra 10%. I hope this helps you with the classwork.